What is crack lacking, gangsters? Welcome back to another Unreal Engine C++ tutorial purely done in C++. We're not going to use any blueprints whatsoever. We're going to create a really cool adventure game, and I'm going to give you assignments in this, well, mini course, so to say. But let me show you what we are going to create. So over here, as you can see, we have a nice little foggy level. And if I hit the play button, we will notice that we have a knight who can attack. And if you can see over there, we have a skeleton who's going to start chasing us, and we can change his speed and all of that stuff. We can run away from him, he can attack us, and he dealt a little bit of damage, and you get the point. The idea over here is to attack the skeletons, kill them, and then reach the end of the level while you have pickups and all of that stuff that you are going to create, because I'm going to challenge you. This is going to be an interactive course, not just you following me. I want you to do the challenges and submit the task down below in the comments, or if you're in my academy, submit them down over there, and I will look them up and give feedback to you. So if you want some interactivity and learn, and this is not a beginner tutorial, by the way, this is for intermediate users who already have created a few Unreal Engine games, and you want to learn also C++ along the way, well, this is the course for you. Just, watch it, check it out, hit the like, subscribe, and all of that stuff. And if you want more, my academy or link to it is down below. So yeah, thank you for watching, subscribe, and all that stuff. I'll see you, well, in the next part, because we'll create this game right now. Okay, my fellow game dev homo sapiens, let us create our game. Now you can download this starter project, which is the one that you see right now on the screen. Link is down below. Just go on awesometools.com and enter your info and you will receive this project. Also, you will be able to download the complete project. And before we start, this is an intermediate tutorial. So if you are a complete beginner, go watch my beginner tutorials so that you don't get lost over here. Now, one thing, or the first thing that we're going to do is go here in the C++ classes, the mist, and I'm going to create a new C++ class, because why else should we go in the C++ classes? Anyways, I'm going to click here character because we want to inherit from the character. Click on next, and the name of my class is going to be knight. Very simple, very clever, very creative. That's all me. Okay, if I can take the credit for that, and you can, oblige that in the comments down below. So of course, Unreal Engine, it's competing to be the slowest engine in the world when it comes to compiling stuff. I'm also going to lower my volume because look at that. It's almost at 100. That will probably break your ear, whatever is it called inside. Anyways, I can sing to you while we are waiting for the compile to complete. I know you like this. So, yeah. So it took way too long for this to compile. Even my singing could not fix that, so I had to cut it out. Anyways, here we are finally. I have aged a little bit, but no biggie. Let us continue. Now over here we have the knight.h file and the .cpp file. Given the fact that this is an intermediate tutorial, I'm not going to bore you with typing out the variables. So what you're going to do is you will find this file, which is a text file for knight.cpp, and also you will find the same one for the knight.h. Let me just find that bad boy. Here it is, knight.h. This is also in the file or in the folder that you have downloaded with this project. So I'm going to copy all of this, and this is again knight.h. So you need to do that, and let me just go back in my project. There you go. And hopefully, there you go. So just copy all of this and go inside of the .h file and paste it. There you go. Simple as that. Everything is pasted. We have everything what we need. Again, going back now to the .cpp file, which is this bad boy over here. Copy everything you see here and let's go and paste it in the .cpp file, of course, in our project. So make sure that you do that. It has all the includes and everything so that you don't have to worry, because again, as I said, this is, now let's go here and compile it. This is an intermediate one. I don't want you to be bored with typing out variables and yada, 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 because it will take us a lot of time to type all of that out, and I don't have that time, okay? So there you go, compile and save that. So everything is compiled, and I can close this, and I can also close this one as well. Now, over here in the project settings, in the input, you will notice that everything is set up. I have thought about you. I love you. Everything is set up so that you don't have to worry at all, because, that's me. So let's go inside of our class over here in the .cpp file. And inside of our knight, which is the constructor, this is where the magic is going to happen, or this is where we're going to first start, creating everything. So the first thing that we are going to create is going to be our camera arm. So camera arm, and that's going to be equal to create default sub-object of uSpring arm component. There you go. Over here in the text, you're going to give it a name, and that name is going to be camera arm. I mean, simple as that. It cannot be more simple, okay? We are also going to go here and create camera arm is equal to set up, or actually we need to call it set up attachment, and we're going to attach it to the root component like that. We are also going to say here for the camera arm, be use pawn control rotation is going to be equal to true, and we're also going to say camera arm right here target arm length, that's going to be 150.0f, which is going to be how far away the camera arm is going to be from our player or the character or the pawn, however you want to call it. I'm also going to create a camera which is going to be equal to create default sub object, and that's going to be uCamera component, not camera amin, component. There you go. With a text over here that I am cleverly going to say camera. There you go. Now over here, camera, we're going to set up attachment, and we're going to attach it to the camera arm because why not? And we're going to attach it at the spring arm component and colon socket name. If you don't know what this means, this is basically going to attach the camera at the socket with the given name, of course, here. And if you still don't understand this, I teach this in my Game Development Academy where you get more advanced tutorials. And I said this is an advanced tutorial. If you don't know this, then you're probably a beginner. Go watch my beginner stuff. So camera, be use pawn control rotation is going to be equal to true as well. Next, we are going to create the collision. So I am going to create, basically this is a box component. So sword collision that's going to be attached on the sword itself. So sword collision, create default sub object of uBox component like that. And of course, inside we need to paste the text. So it's not Rex. I'm not giving a name to a dog or whatnot. So I'm going to call this one sword. I'm just going to call it sword because that's me, you know, creative dude. Sword collision is going to be equal to attach to component, and we're going to attach it on the mesh. But over here, I'm also going to say F attachment transform rules, colon snap to target, including scale in the F name, and it goes like this. There you go. We are going to say weapon socket. This is going to search for a socket that is on the mesh. And did I have everything correctly? Yes, I do. So, you know, that error now is go. It's away and it's back. Anyways, you get the point. Let me just compile this and see if everything is okay. It should be okay. I should have not made any mistakes. I did actually make a mistake. So let's see what I did. Attach to component, get mesh. F attachment transform rule snap to target including scale, F name, and I provided here the name. Cannot convert void to uBox component. Let me just see over here. What did we do? Okay, there you go. Not equal, but it's this one. We are calling the function. You probably saw that, but stupid me. Anyways. This is going to attach this sword collision by using the mesh, which is going to be the player knight, and it is going to search for the socket that we named weapon socket. Of course, I have already prepared that is prepared for you, but if you want to learn more about this, you have that in my academy where I explain it in detail, which is basically just a part of the body on the mesh, and we gave it a name. But if you want to see how that is done, you have that info in the academy. Now over here, character turn rate, that's going to be 60. I'm also going to say be use controller rotation pitch, and that's going to be false. Be use controller rotation yaw. So controller, again, let me just copy this over here. So it's not pitch, it's yaw, and that's going to be false. And it's not pitch yaw roll. There you go. I'm also going to say get character movement and be orient rotation to movement. That's going to be true, which is going to rotate the character in the movement direction. We're also going to get the character movement, and we are going to rotation rate or set the rotation rate to F or rotator, and that's going to be 0.0 on the X, 600 on the Y, and 0.0 on the Z axis. I'm also going to set over here the health and all of the variables. So max health, that's going to be equal to 100F. And by the way, that's all here that you can take a look at. So we have over here an enum that is going to determine the status for the walking, running, and that. We also have the stamina status, which is going to determine our stamina. Can we run? Can we recover? And all of that stuff. Over here, you can see the different variables that we have declared that I assume you took a look after we have copied all of this, because I don't have to go and explain what is a character turn rate, max health, stamina, mana. I mean, I already said in the beginning, this is not a complete beginner tutorial. So we have the health. Next, we have the max stamina, which is also going to be equal to 100. We have the max mana, which is going to be 60. We also have the health, which by default is, 100F. Why not? We have the stamina, which by default is, again, 100. And we have the mana, which by default is 0, because why not again? I have a lot of fun creating this stuff. So walk speed is going to be equal to 200. My run speed is going to be equal to 500, because this knight is apparently a Speedy Gonzalez, and I am, and it's capital S. There you go. I'm going to say the knight locomotion, so it's simply knight without the E, so knight locomotion status is equal to, now it's with an E, and it's going to be the walk one. There you go. And is this indentifier? Let me just see here if I made a mistake. So just quickly, knight, yeah. Over here, add T. I believe that I fixed this issue, but apparently I didn't when I was preparing this project, but just add here T, so knight locomotion status, which now will remove this error over here. We also are going to say B run key pressed, if it's not going to give me, so B run key pressed, that's going to be equal to false. We didn't press the key to run. B move forward, backward is also equal to false. B move right, left is also equal to false. Knight stamina status, that's going to be equal to E knight stamina status, and it's going to be normal, because first we're starting with the normal. Stamina usage is going to be equal to 15.0F, and our minimum run stamina required that we can run is going to be 30, because this knight is not Usain Bolt, and BLMB is equal to false, is the left mouse button pressed, and B combat is also equal to false. Sword damage is going to be equal to 40.0F, and there you go. This is basically setting up everything that we need inside of the constructor. Now over here in the begin play, we are going to attach the functionalities. For example, here for our sword collision, we are going to set the collision enabled, and that's going to be E collision enabled, colon, no collision. There you go. This is for the starting part. Of course, when we attack, we are going to enable the collision so that we can actually deal damage to the enemy. How else are we going to, and over here, I almost forgot the semicolon. How else we are going to attack the skeletons and destroy them? Next, our sword collision, we are going to say set collision object type, and we're going to set that to E collision channel, colon, world dynamic. There you go. We are also going to say sword collision, and this is going to be set collision response to all channels, and this is going to be E collision response, and not E collision channel, it's actually E collision response, colon, ignore. This is in the beginning, of course. As I said, when we attack, we're going to enable all of these things. So sword, and then we're going to say set collision response to channel, there you go. And over here, I'm going to say E collision channel. And this is not like a channel on your TV. Don't get your channel trying to, turn on the TV. No. This is just, in the code, okay? So pawn, there you go. And over here, I'm also going to say colon and enter collision response colon overlap. So it's going to overlap every pawn, which basically means the enemy. Next, I'm going to say here sword collision, and I'm going to say on component begin overlap, add dynamic like that. And I'm going to move this down so that we can see. And by the way, if you want to change the size of this, you can just hold control and move your mouse wheel. So I'm moving it backwards and it's, lowering the size or resizing it. And here it's a bigger size and you get the point, okay? You get the point. This is my size. So add dynamic, this, and sign at a knight, colon, sword on overlap. It's actually sword on overlap begin. There you go. It's going to attach this function in the on component begin overlap. So when we overlap with the sword collision, which is a collision box, and it will overlap with the enemy, then we will detect damage, or we will actually detect that collision. So over here, it's not on begin overlap, but it's on end overlap, and over here, not begin, it's end. Because, in the case we want to know what happens when the collision ends, here you go. This is where we'll get that info. Now I'm also going to say set instigator. That's not investigator, so no private investigator here. This is a pawn responsible for damage. So basically, this one is going to be a knight, colon, get controller. So the controller from our knight is going to be the one responsible for dealing damage to our player. Now, what I also need to do is go and set up the input component. And in order to do that, I am simply going to copy and paste it so that we don't have to deal with that. There you go. Over here, you can pause the video right now and copy this. So it's inside of set up player input component, because we will not learn anything new over here. This is just the binding the axis move forward, backward to the functionalities that we want to, tackle. You get the point. There is no point you watching all of this. Just pause the video right now, or download the complete project and copy all of the lines of code you see inside of the player input component. So I'm just going to move it over here. Now you can pause and you can copy all of this, and I'm going to move it a little bit down and you can pause and copy all of this here, which is going to bind all the functionalities and yada, yada, yada. Now let's go over here inside of the move character forward and backwards. To move the character forward, I'm going to say b move forward backward. That's going to be equal to false. Next, I'm going to say if controller, so if we do have the controller and he is not equal to null PTR, meaning the controller of our knight, and the value over here that is pass on to the function is not equal to, so if the value is not equal to 0.1f, and again, we're not in the combat, and one more time, knight locomotion status, so it's actually knight locomotion status is not equal to knight locomotion status that. So when all of these are in place, when we have the controller, so the controller is not equal to null pointer, the value that is here, that means if we press the buttons to move the character forward or backward, that value is not equal to 0.1. And we are not in the combat, so we're not attacking the enemy, and the locomotion status is not equal to that. What we're going to do? Well, we're going to say over here constant f rotator is equal to rotation, or actually call it rotation. That is now equal to controller, and from here get controller rotation. Here it is. Next, we're going to say constant f rotator, rotation, tation, there you go, 0.0f, rotation dot and 0.0f, there you go. And next, I am going to say constant f vector direction, and we're going to get the direction now by using rotation matrix, and we're going to say rotation, and then we're going to say get unit axis, And from here, we're going to get the e-axis, colon, x-axis, which is going to give us the direction. So how this functions behind the scenes, I have no specific idea. I did give explanation to this, what, approximately how it works behind the scenes in my Game Development Academy, because I tend to not go in depth with functions that are already created or built in, because I can just use this functionality to get the y or x-axis rotation from here, which will give me the direction where the player is going. So now I can say add movement input in the direction using the value multiplied with 0.2 so that it is, have some, smooth movement or whatnot. Now over here, if you were wondering why did we set here this to be false, because now over here I'm going to set that to be equal to true. And there you go. This is going to move our character forward and backwards. Now to move the character left and right, I'm basically going to copy this code and I'm going to paste it over here. So move him left and right. And first, we are going to set this to false if the controller is not equal to null pointer, if the value is not equal to 0.0 over here. Now, why you are wondering, or why did I set here if it's not equal to 0.1 and here 0.0? Well, the secret to that is in the academy. Over here, if we are not also in the combat, and if the locomotion status is not equal to that, meaning we did not die, then we are going to say over here, as you can see, rotation, getting the control from the rotation. Here from the yaw rotation, we are also going to create it the same way we did in the above example, getting the direction not the same way, but here we're going to get the unit axis, but this time for the y-axis. And now we're going to do everything else the same. That would be pretty much it. The last two things that we are going to do before we test this out is over here in the turn character right or left. We are going to say add controller yaw input, and I'm going to get it from the world. So get world, get delta seconds, and I'm going to multiply that with the character turn rate and multiply that with the rate that is being here used as the parameter. Now it's get delta seconds, which is a function, so I need to call it as one, and I'm going to copy this as well and paste it over here. And this time, this is not going to be the yaw input, but it is going to be the pitch input. There you go. So get the pitch input from the get world, get delta seconds, multiplied with the character turn rate, and then multiplied with the rate that we have here, which is either going to be -1 or 1, depending on if we are moving the mouse up, down, left or right or whatnot. Now, for us to test this out, what we need to do is, and let me just make sure everything is there, down rate, yeah, everything is okay. Let me just go here and compile that. So we need to make sure that our code is okay, which, 100% it is okay because it's me, the best coder on whole YouTube, on whole world or whatnot. And there you go, compile is completed. What we need to do is go here in the content, right click and create a new folder. And this one is going to be blueprints. And I am going to right click and create a blueprint class, which is going to inherit here from all classes. And I'm going to search for the night class, which is the one that we have just created. So click on it, select it, BP night. This is the name of the class. How else am I going to name it? You get the point. Now, when I open this bad boy, this is what we are going to see. We have all of these things here. Now, before we tackle this, I'm also going to right click blueprint class and create one that inherits from game mode. So let me just find it here, game mode, and I'm going to call it BP night versus, I'm going to call this one night versus skeleton or night platformer. So night adventure, actually, this is an adventure game. So BP night adventure game mode. Now the reason why I did this, because we need to go in the project settings and maps and modes, and from the game mode base, that is, select the game mode, and the default pawn is going to be the knight, so that we can actually spawn our knight and we can, test out everything what we did, so to check if it works. But before we do that, let's go here inside of our knight, compile and save. For the mesh of the knight, I'm going to click here and select the, not the skeleton, knight character. This is the dude we want to select. And what I'm going to do with him is go here and set his, first lock the scale, set the scale to 0.15 on all 3 axes, because, you know, the knight was an enormous weird dude. I'm also going to lower him, -40, and rotate him by -90 degrees. There you go. Now, next what I'm going to do is the sword collision is this big thing that you see here. Now, what I'm going to do is compile and save that. Let's see where the sword collision is. Here it is. Let me set the sword collision size on the X to 2, on the Y over here to 0.1, and on the Z 0.15. So this is going to be, as you can see, the swords box extend, which is basically the size. You get the point. And let me compile and save that. Now, what we also need to do is attach select this character over here and attach a static mesh. But before we do that, which is going to be the helmet and everything else, I'm going to change the capsule size to 39 over here and 21 so that it is a little bit, you see, it's a little bit smaller. We don't want a fat knight. So select the mesh and static mesh. Here it is. And I'm going to call this one helmet. There you go. And attach over here, search for helmet. So helmet. Voila. And here it is. Look at the helmet. It's very crazy. The parent socket here, I'm going to click and search for the head. Voila, which is going to set it. Look at that. But now it's, you know, too huge. And it looks a little bit, well, not a little bit. It looks weird a lot. And I'm going to set here the scale to 0.01 on all 3 axes. There you go, which is going to set the size to the, you know, normal size. I am also going to rotate this bad boy to 270 degrees and move this up on the x-axis 0.06, on the y-axis 0.86, actually negative, it's going to be minus, there you go. And on the z, for the transform, we are going to set that to -0.06 as well. There you go. It perfectly fits now the head of our crazy whatever character. I am going to copy this, so Control-C and V to duplicate this helmet basically, and I am going to rename this one to shoulder pads. And over here we're going to select shoulder pads, and where are the shoulder pads? Where are they? So compile and save that. Okay, I cannot see them. So what I'm going to do here, 0 on the X, Y is going to be -0.2, Z is going to be -0.26. There you go. I'm going to set the rotation to -90, 0 here, 0 here. The scale is going to be, and I'm going to remove this lock here, so 0.012 on the X, 0.012. Why did I remove 0.012? There you go. And we do need to set the shoulder pads, and over here the socket for them is going to be the neck. And finally, here they are. I can now see them. Look at that. So finally see the bad boys. And they can be, let me just set here the snapping grid to 1 so that we can snap them a little bit better. Exactly on the shoulders of our character, something like that. There we go. Don't worry about this being on his arm or inside of his arm, because when we have or add the animations, it's not going to be like that, okay? And last but not least, let me just select the character, static mesh, and this one is going to be our sword, because why didn't it rename it? So come on, sword. Okay, so sword mesh, there you go. For whatever reason, it was telling me it has the sword and I don't see it anywhere. So sword, here it is. And I'm going to set the palm R as the parent socket. And of course, look at now, you see this sword. It's crazy. This can be some kind of special attack for a weird game. So let me just locate this bad boy if I can. Yeah, I cannot see him with this because of the sword. So let's go here and set the scale. First, lock everything. And the scale is going to be 0.01 on all 3 axes. Finally, there you go. And the rotation for this one is going to be 450. Is it 450? And over here, 450 degrees. There you go. Look at that. And that would be pretty much it, I believe. We can only take the sword collision and probably set it over here. So minus 1.75 on the x-axis, and that would be it. So now we are done. Compile and save that. So this is how our knight is going to look like. Again, compile and save. And make sure again that you here select the knight as the default pawn class, because now we can go here and test it out. If I hit the play button, there we go. We have the knight. We can rotate around him. We can move, and look at that. He is facing the direction where he is moving, but he looks like a weirdo sliding. I don't know. How can I call him? Some weird ass dude who slides. We cannot even run because if I press shift now, it will not do anything because we didn't code that. And yeah, that would be for the knight. There you go. Moving forward, let us go here in the C++ classes, right click in a new C++ class, and over here I'm going to search for the anim instance, because this is what we're going to inherit. So inherit the anim instance, because now we're going to create an animation for our character, and I'm going to call this one not my anim instance but knight character, because he is our knight in Shining's armor and whatnot. I mean, yours, probably not mine. And yeah, moving forward. Let us wait for this to compile. Hopefully I will not have to cut it out or sing to you, but I'm so close to singing to you. And there you go. You are saved. I will not be singing to you. So let's go here. Now I'm just gonna sing. And there you go. So what we're going to do here is we're going to create a few public variables and functions. The first we are going to override, so virtual void native initialize animation, and this one's going to be override, as I said, because we're going to do our own initialization. New property, not proper2, it's property edit anywhere, so anywhere. And blueprint, so blueprint read only value, which is going to be our character, so character speed, voila. U property, and this one is going to be edit anywhere, and blueprint read only, and this one's going to be our class a pawn, which we are going to call cleverly pawn, and new property, which again is going to be edit anywhere, which means we can edit it on the blueprint directly, blueprint read only, and class a knight, and it's a pointer, so we need to add an asterisk or a star, however you want to call it, and new function. This one is going to be blueprint callable, and I'm going to call this one void update character animation property, so properties, there you go. For this one, right click on it and go here, quick actions and refactoring, and click here to create the definition for our bad boy. Next, we need to wait for Visual Studio to have mercy upon our poor souls and create finally that function. There you go. He did that. For whatever reason, I cannot do the same thing for our native initialize animation. So what I'm going to do is go here and say void and call and call the function, and over here I'm going to paste this, and voila, there you go, and now we are done. So now we have both functionalities here. We do need to do one more thing, and that is over here, include the knight.h file, because we are using the knight over here, as you can see. And what's going to happen inside of this function, this is the initialization function, by the way. It will be run automatically when the blueprint animation is, created or run. And we're going to say here if our pawn variable that we have created is equal to null pointer, so null ptr, then we're going to say pawn is going to be equal to try get pawn owner. By the way, because this is an if statement with a single line of code, we can omit the curly brackets. one of my students was confused by this. There's nothing to be confused about. If you have only one line of code after the if statement, you can exclude the curly brackets. If you have more than one line, then you need to put them inside of curly brackets. That's all there is to it. So over here we can say if pawn, then we can put this inside of curly brackets again or omit it, because over here we have only one line of code. Then knight is equal to a knight, casting it, and we're casting the pawn that we have over here. Now try get pawn owner is going to get the owner of this anim instance, and I'm going to leave these as is like this so that you can see both examples. One is without curly brackets, one is with curly brackets, and both can work. So that's the whole point here, nothing to be confused about. Inside of our update character animation properties, I'm going to say if pawn is equal to, so if our pawn is equal to null pointer, so null ptr, we can say over here pawn is equal to try get pawn owner in case our pawn is equal to null. Now, of course, this is just as a precaution in case you forget to call this. You can use it for testing purposes and then omit it later on. That's up to you. Over here, I'm going to say if pawn is not equal to null ptr, so we have our pawn that we got over here, then what I'm going to do is I'm going to say f vector, and I'm going to call the speed is going to be equal to pawn, and from here get the velocity from our pawn. I'm also going to say f vector, and this is going to be my horizontal speed, which is going to be equal to f vector, and I'm going to call it speed.x, and from here speed.y and 0. And why am I saying speed? Anyways, you get the point. My character speed variable is going to be equal to horizontal speed dot size. Size is going to, if I hover over, get the magnitude or the length of this vector. If you don't know what are magnitudes, what is the magnitude of a vector, you can learn that in my academy. Over here, I'm going to say if knight is equal to null pointer, then I am going to fetch me a knight because I like knights. So over here I'm going to say knight is equal to cast into an a knight, and I'm casting the pawn that we have over here, and there you go. So what's up with this? What are we going to do with this? Well, simple. We are going to compile it. So Control-Shift-B to compile this. Hopefully this will not break Unreal Engine, because while working on this, Unreal Engine broke a few times, as is for no reason, because Unreal Engine is like that. It likes breaking up. So let's go here inside of animation and anim blueprint, and we want to inherit the knight character anim instance, and we want the knight character skeleton for this. So over here select OK. Now call it bp and underscore knight underscore anim. This is I'm going to call it, and double click it now so that we can open it here. We can see everything clearly. It's really cool and yada yada yada. You get the point. I'm going to right click over here, and I am going to create a state. So first I'm going to get me myself a state. That should be a word. Add a new state machine, and I'm going to call this one knight state. And I'm also going to cache. So I'm going to cache state. So over here I'm not going to call it save pose, but locomotion cache of the knight, and I'm going to plug these two together and double click this bad boy to open it. So what's gonna happen here is I'm going to create a state which is going to be our idle/walk, and I'm also going to right click and create a state which is going to be a run, and you can assume which is the first state. That's going to be the enter state, and it's going to be our entry over here. Now in our walk over here, what's gonna happen is I'm going to get this idle walk montage that is prepared for you, which you can see right here. If you don't know what is a montage, it's basically a combination of multiple animations, in this case idle and walk, and it has a parameter that we can plug in, which is going to be our character speed, and based on that parameter that we plug in over here, we are going to change the animation. Simple as that. If you don't know this, never heard of it before, you can learn that in my Game Dev Academy. Inside of the run, we are going to get here, let me just see, this is the death, idle This is left. Where is the run animation? Here it is. So I'm going to take the player, knight, anim, human, armature, run, but it's actually run with the sword. So sword attack, run sword, here it is. Run, sword, right. There you go. Plug this in, bad boy, over here, and voila. We do need to have transitions from run to idle walk and from walk or idle walk to run. And let's go here inside of the condition. The condition from going to idle walk to run idle is going to be getting the knight and not cast to knight, but we need to get the knight. Here it is. If you're wondering who is this bad boy, well, it's this dude over here. There you go, this one that we fetch over here. So we need to fetch him also in the blueprint, and from him I'm going to get the locomotion status. There you go. So get the knight locomotion status, and I'm going to test it if it's not equal to byte, and it's going to be 0, and plug it in over here and compile and save that. Now, why am I testing if it's not equal to 0? Because the enumerations are also represented as, indexes, let's call them like that. So if I go here, this right here, look at that. So we have over here the walk. This can be 0. This can be 1, this can be 3, or it is actually, in fact, like that. So we can test them. We can test them also using numbers. Now let's go here inside of our run back to the walk idle or idle walk. Again, we're going to get the knight, and from him get the locomotion. It's locomotion status, and from the locomotion status we're going to test if it's equal to. So over here it needs to be equal to. There you go, walking, and compile and save that bad boy now. The last step is that we need to go into the anim graph, and I need to fetch myself the cache state that we have cached over here. It's not cache like money, so don't get excited. We are going to get the locomotion cache, and we're not going to plug it in directly like this, even though that will work. But instead what I'm going to say is get the slot, and we are going to get the default slot, and don't get your, don't think about nasty things when I say, slot. Okay, so I am going to plug this over here, but the default group is not going to be the default slot. Instead, it's going to be the combat one. And compile and save that, and you will notice now we have the animation over here on our knight. He is in the default state. He is all cool and stuff like that. And what is this combat group? Well, because we have the combat montage, which is here, as you can see, inside of the asset browser. We will need to be able to interrupt the current animation, no matter what it is, idle, walk, whatever. You have other animations, they also need to be interrupted if we attack. And in order to do that, the attack animation, or in this case, combat montage, needs to be in line with the default group. You can learn more about that in my academy. I don't want to repeat myself. Now, we also need to go inside of our event graph, which is here, because from our update, you see event blueprint animation update, we need to call update character properties. And this is needed because if I go inside of the code, let me quickly do that. And in the CPP, you see we're updating the speed by getting the speed from the pawn. And that is needed because we need to set over here if our knight can go into walk idle based on the character speed. If I go here in the idle walk, which is our blend space, you see when this value over here, the horizontal one, and for whatever reason, it's not allowing me to move it. Can I move it right now? Why isn't it allowing me to move it? Okay, here it is. There you go. You see, when it's right here, look at that. You can see the animation of the player based on where the value is. So, as I said, I talk more about this in the Game Development Academy, which you can check out. Link is down below. So next, what I'm also going to do is I'm going to get all the notifications that I set up. So here, add anim notify event. We want the stop animation, so stop anim event. We also want to right click over here and we want to activate collision, which is when we attack. We also want to deactivate collision, so it's right here, deactivate collision. There you go. We also want the death as well, so right click here and end that, not end attacking, but end death. There you go. So what is this? Well, if I go in the combat montage, you will notice over here, let me just find where is the, here it is. I cannot see because of my mic. Look at all of this here. These are animation events. Stop anim, end death, activate collision, deactivate collision. And these will be triggered, which are these notifiers, as you can see. These will be triggered based on where the animation is being played. So if the animation plays up to here, where it currently is, look at that over here. And let me just click here, play. Okay, actually stop it. And when the animation plays up to here, look at that. So he's swinging his sword. We will hit this activate collision event and it will be called, which is this event over here, if you are wondering. So let me just find it, activate collision and enable weapon collision and disable weapon collision that we will, attach right now. And how can we attach that? Well, going back over here, inside of our animation, we need to get our knight. So get the knight. And from the knight, to stop the animation, what I'm going to do is call stop combat montage. There you go. So here it is. And from here, I'm going to call enable weapon collision. Voila, there you go. So plug that in over here, copy this and paste this bad boy here. For the deactivate, I'm going to go and call disable weapon collision like that. And for the death, we're going to call end at death and plug this in over here, compile and save that. So what are these functions? Well, these are functions inside of the class. Enable weapon collision, disable weapon collision, and at that, if you go over here in the .h file, you will see that this is blueprint callable, meaning we can call these functions that we have declared here inside of blueprints, and we're doing that right here to inform the player whatever code we put in those functions will be executed when these animation events are being called. Simple as that. And I have this in more detail in the Academy. Now what I'm going to do is go here, save everything, and BP Knight, compile and save that, and select the mesh character over here. And for the animation anim class, let's go and select the BP Knight animation, and automatically you will notice him being animated in his weird whatever idle state. Now compile and save for all three of these. Make sure that you do that. And because we have attached now the anim on the BP Knight, we can go here, hit the play button, and look at that. Now the Knight is not in his T weird pose, and he can actually, look at that. Now he's being animated. Look at those little feet he has. Look at those little feet. Now they are in the ground. What you can do, are they in the ground? Actually not. I thought because they're so little and tiny. Now you can, if he is in the ground, actually the feet, you can change that inside of the blueprint over here by setting his collider, and a little bit maybe they're in the ground. I don't care about that. What's important is the following, that we can actually move and see all of the animations and yada yada yada. Of course, if something's not clear, make sure that you ask in the comment down below, but you should know that my priority are students in the Game Dev Academy. I leave no questions unanswered there, so if you want my help 24/7, it's right link to that is down below. Anyways, that will be for our animation for the Knight. Moving forward, we can go back inside of our Knight.cpp and continue coding, of course, because we have a lot of things in place. Now we can go here in the get camera, and I can return, this is the camera, and I want to also return the camera arm. So camera arm. There you go. Also over here we can return the camera. For the decreasing health, what I'm going to do is simple. We're going to take the health, subtract the amount from it, which is going to be passed over here, and then test if our health is less than or equal to 0.0, then we're going to die. Not close connection due to security and whatnot. Instead, we're simply going to die. Not in real life, you and me. I mean, someday we will, but in the game. Okay, so over here for taking the damage, what I'm going to do is the same amount. So from here, we are going to take the health, and it's health. So let's go health and minus equals the damage amount. And from there, we're going to test if our health is less than or equal to 0.0f. And from here, I'm going to call die. And we're going to test here if our damage causer, so damage causer, or who has caused the damage, is the enemy that we still didn't create. Then we are going to do certain things. You can do whatever. I want you to be crazy. I want you to be creative and think of ways what you can do based on if the damage is dealt by the enemy. Hint, hint, you can perform some special effects and whatnot, but there you go. I also want you to rewrite these lines of code. Think of it, on your own way, how you can better structure this, because this is also an interactive tutorial. It's not only about you watching me typing things out, it's also about you doing assignments and then give that feedback down in the comments down below. This is to give you a taste what we do in my Game Development Academy. This is how we function, of course, on a much higher level, where if necessary I also take the projects from my students and review them and all of that stuff. So if you're interested in that, link is down below. Now in increasing health, I'm going to say here health plus equals amount from here, and I'm going to say if health is greater than the maximum health, not max mana, because this is health, then we're going to set the health to the maximum health, not allowing it to pass over the maximum allowed health. And your assignment will be to add those health boosting items, so boosters, inside of the game, and I also have examples for that in the academy. Over here, to decrease the mana, I'm going to say mana minus equals the amount of the mana, and if our mana is less than or equal to 0.0f, we're going to set mana to be equal to 0.0f. That will be it. To increase the mana, we are going to increase it by adding to it the amount, and from there we are going to test if our mana is greater than the maximum mana, then we're going to set it to the maximum value, not max align, but max mana. There you go. When we die, what's gonna happen? So over here, when we die, I'm going to say you anim instance with an asterisk because it's a pointer, and I'm going to call it anim instance is equal to, we're going to get it from the mesh, so not get memory, but get the mesh, and from the mesh, I'm going to get anim instance, not anum, it's anim, get anim instance. And I'm going to test if we do have the anim instance. Then we are going to call the anim instance, and we are going to play, so montage, so it's montage, play, finally, I finally did it, so it's night, anim montage, and actually night, anim montage. Did I call it like that? Let's go here in the night.h and find the montage. So where is the montage, where is you? Here it is. And for whatever reason, this didn't change when I changed it when I was preparing this project. So it's night anim montage, okay? And we're going to play it with the speed of normal, so 1.0, and I'm also going to call the anim instance, and from here I'm going to say montage underscore jump to section, and I'm going to jump to the section named, passing it here in f name, and that name is going to be that because we are in the die over here, see? Die functionality, so we're going to jump to section that in the montage animation because we said that the montage is composed of multiple animations into a single animation. We can have sections separating those animations from each other. If you want to learn more about this, Academy. Link is down below. Now over here, I'm going to call set knight stamina status, or actually locomotion status, and we're going to call knight locomotion, not stamina, man, locomotion status. There you go. We are going to set it to that because now the knight has died, and that would be it. So it's set knight, and I believe that I also over here it did not change, so also you need to add T over here. Sorry for this, but actually I changed this before I provided these files, and for whatever reason over here in my file, it's like this. I don't know why. Anyways, you get the point. So for the locomotion now, so this is set locomotion. We're going to say over here knight locomotion, and yeah, of course we need to call it here with T also. So set the T here as well. So knight locomotion status is equal to status, which is the parameter that we have here. And I am going to say here if our knight locomotion status is equal to knight locomotion status, and if it's run, we need to change the speed of the movement. So here we're going to say get character movement. And from here, I'm going to say max walk speed is equal to run speed. And next, I'm going to say here else and do the same thing exactly. And copy it, but here the max walk speed is going to be the walk speed instead of the run speed. Also over here, setting the stamina status, I'm going to say knight stamina status is equal to status whatever, and if the run key is pressed, we're going to say be run key pressed is equal to true. If it's not pressed, meaning if it's released, we are going to say false. There is no brainer what this is. For the left mouse button, if it's active, it is going to be LMB, so LMB BLMB, there you go. It's equal to true if our knight locomotion status is not equal to knight locomotion status that, and over here we need to add that. Then what I'm going to do is call the start combat montage, which is going to be our combat montage. Simple as that. Over here I'm going to copy this. Actually, this is left mouse button not active, and this is B run key. Okay, this is okay, and this one is not active, so it's LMB basically, this right here, and it's not true. It's equal to false right now. And if it's not active, that's that. And moving forward for the combat, we're going to say if we are not in the combat, so exclamation mark, which makes what's after the opposite. So if we are not in the combat, and if the locomotion status is not equal to locomotion, so locomotion status, and let me just go here, knight locomotion status that. So if we are not in the combat and we are not dead, then we're going to say combat is true because now we are in the combat. We're going to get the anim instance, so anim instance with a star because it's a pointer, calling it anim instance, and that's going to be equal to get mesh, and we are going to get the anim instance from the mesh, and then we're going to test if we do have the anim instance. And by the way, I want you to rewrite this code because we're using the same code here, this one over here, and this one over here. So basically, it's the same code that we get the anim instance. I want you to rewrite that, and the lessons that will help you rewrite this, you can find in the C++ and Blueprints design patterns, which is the third section or fourth section in the Academy that will help you rewrite this. And if you're watching this on, YouTube, you can, do it on your own. Search online if you can find for answers, and then you can get back to me in the comments down below and I will check it out. So if we have the anim instance here, we're going to say anim instance, and we are going to say montage play, montage underscore play, and I'm going to call the knight anim montage, and we're going to play it with the 40% of the normal speed, so 1.4, so 40% faster. It goes like that. So anim instance, I'm going to say montage underscore jump to section, and we're going to jump at the F name attack 1 section, and we are going to do that with the night and a montage. And there you go, it's going to jump to that section. What we also need to do is over here in the stop combat, we are going to say combat is equal to false. And then from here again, we're going to get the anim instance. I'm going to copy this again, rewrite this code. This is up to you. This is your assignment. Rewrite it, make it better. And if anim instance, we are going to remove all of this here, and I'm going to say anim instance, and from here stop montage or montage stop 0.0f, which is going to stop the montage. Again, as I said, this is your assignment to rewrite the code that will, you get the point. Anyways, what I am also going to do right now, we have the on sword overlap, we have the sword overlap, and this we need to do. So over here we can test if we do have the other actor, meaning we have collided with the skeleton. So this will be done when we create the skeleton. Because we still don't have the skeleton, we need to get him, we need to deal damage to the skeleton and all of that stuff. But I'm going to continue and go here in the collision enabled. So when we attack, we are going to call sword collision, and from here set collision enabled, and it's going to be e collision enabled, and it's going to be query only. And we're not going to use query and physics. You can learn the difference between that in my academy. So query only and query and physics. And over here in the disable, I am going to copy this and paste it over here. And I'm simply going to say no collision because we don't want collision anymore. For the instigator over here, we're going to say sword instigator is going to be insti voila. And at that, when we die, I'm going to get the mesh from the player. Get mesh, and from him I'm going to say b pause anims is going to be equal to true, which is going to pause the animations for the player. Get the mesh also, and we're going to say b no skeleton update. So b no skeleton update is also going to be equal to true, which is not going to update the skeleton. It's not going to play the animations. Our player is dead, and then we can also destroy him and all of that stuff. So Control Shift B to, compile all of this. So make sure that we compile it and that I didn't do any oopsies and everything is okay. It has succeeded and Unreal Engine didn't crash for whatever crazy reason. And we would be able to go and test this out. Now, before we test it out, we do need to go here in the night anim, or night BP, excuse me. Over here for the hit particle, while I am here, I'm going to say PS blood, and I want the blood spurt too. Over here for these values, walk speed, we can set that to 600, and we can set the run speed to 1500. I don't know how to say American numbers. And over here for the montage, I'm going to take the night combat montage, not the NPC, but the night combat, compile and save that. We need this in order to be able to attack. Now, this sword can go... Actually, it's okay. I believe it's okay at the right... It's at maybe just a little bit forward like that, because it looks a bit weird. It's like we are holding it with the back of our palm. Now he's holding it directly in his arm. Now make sure that you compile and save that. So now we can go and test this out. If I hit the play button and we go here in the game, I can move my character, and if I attack, look at that, he's attacking and he died and he's rolling over. So what is going on? Let me just go here and stop. And we have a problem. Let me just check here. Attempted to access property night locomotion status. And this is happening over here inside of the, it's right here. So night locomotion status. This is because we changed, I believe this is because we changed over here inside of the script, in the night, we changed the night locomotion status. And what I need to do is quickly go here. And for whatever reason, let me compile that. Look at that. You see, it's not giving me the reference. The type of night reference doesn't match the property night. It's weird. Look at this. If I try to plug it in, let me break the pin. And okay, it is allowing me to, what's happening over here and over here as well. Let me try to unplug it, break it, and plug it in. So it works. The type of night object doesn't match the property night hot reloaded. Let's try it again. Let's try this. Okay, this is also debugging 101. I'm not going to remove this because this is going to show you debugging as well. Also, this needs to be saved. Okay, save everything. Let's do this. I'm going to show you how I would debug this project because currently I have an issue. Look at this, build has succeeded. And if I go here and let's go on the night, compile and save. Let's go here, compile and save. Again, we have a problem. So what I would do here, because it's telling me that I have some issues with my night. This is on top of my head, you know, I don't guarantee this will work, but let's try it out. This is how I debug my projects. What I'm going to do, because it doesn't recognize the night, what I'm going to do here is I'm going to say night character and call my character over here night character. And let's go here, cast night to the night character, cast here night to the night character. And let's build this bad boy and see if this is going to help. I just changed the name because it says that it doesn't recognize, and let me see over here, night. Okay, if night is equal to null pointer, so it needs to test if the night character is not or is equal to null pointer, because as I said in the blueprint, it's telling me, look at this, could not find variable night, you know, before that. So let's go here, remove the night, and I'm going to get the night character. So getting the night character and plugging him over here and plugging him over here. Copy this value and paste it here. So plug this here, plug this here, and compile and save. This is going to work, but this right here is not working. So let's remove it, delete the variable character and night. Get the night character. Now we should be able to plug this in over here, which works. And let's go here and also remove the night. And let's go night character. There you go. And plug this dude over here. And let's compile that. So everything has compiled. Look at this now in the blueprint. It has compiled. Compile and save. And I believe that would be it. Where else do I have over here? Night. Compile and save, and compile and save everything one more time just to be sure. And now we can go and test it out. So if I hit the play button, when we run the animation now, yeah, there you go. You see, because we changed the variable names and we already used the night inside of the animation script and whatnot. That was the reason why this bug has showed up, and this is how we fixed it, basically by changing the variable name. I don't know if there's another way. If it is, make sure that you comment down below and let me know. But here it is. You see, now we can attack, and when we attack, we go back in our state, which is the either idle, only idle. And look at this, I'm moving. So I'm currently moving and I attack because I have attacked. We are playing that animation. We're not playing the movement animation. So we're not allowing the player to continue moving. And the reason for that, or how we are achieving that, is over here in the anim graph, because we're going through the slot combat. And because our combat animation that we saw goes to the slot name default group combat, that is why we are able to play that animation or give it advantage over the walk animation, even though I was holding the button to make the character walk. Now, again, if you want to learn that, that is in my Game Development Academy, where I talk about that in more detail in the specific courses about C++ and blueprints and whatnot. But yeah, this was also debugging 101. I didn't want to remove that. And yeah, this is for the character animation. Alrighty then, enough about me promoting the Academy. Let's go and finish the tick functionality inside of our night.cpp. So what I'm going to do is go here, and here is the tick, if I can find it in the bunch of code that we wrote. And the first thing that I'm going to do is test if the night locomotion status is equal to e night locomotion status. And here I'm going to say that. And from here, I'm going going to return. This is in case that this is equal to that, meaning that the character has died and we have nothing to do here. So next what I'm going to do is go here, float delta stamina, and that's going to be equal to stamina usage, and multiply that with the delta time that we get from the tick, which is the parameter, as you can assume. And next we are going to go inside of a switch and case, and the switch is going to be on the night stamina, so night stamina status. So this is going to be, and this is going to be the case or the switch, and the cases here that we have the normal, we have the under minimum, we have the 0, we also have the recover, but we don't have the default. So I'm going to remove the default because we do not care about the default, do we now? There you go. So the first thing that we are going to do under normal, and here I'm going to give a little bit space, I'm going to test if the B run key has been pressed. So if we press that run key, and over here else if the key is not pressed. So here I'm going to say else, there we go. So if the key is pressed, I'm going to subtract from the stamina because we are running, and here not the delete loader, but we want the delta stamina. So delete that from the, or subtract from the stamina. And next I'm going to say here if our stamina is less than or equal to minimum stamina, so minimum run stamina, basically the minimum stamina that we can use to run, if that is the case, then we are going to set the night stamina status to the E night stamina status, and that's going to be equal to under minimum. There you go. Next, what I'm going to do over here in the same if statement, so within the B key run pressed, I am going to test if B, not oof, it's B, if B move forward backward, or if B move left right. So if we are moving forward or backwards, or if we are moving left or right, then I'm going to set the night locomotion status, and we are going to set that to E night locomotion status run, because we are moving. Otherwise, I'm going to take this, so copy this line of code and go here and have the else statement. By the way, you can omit the curly brackets for both of these because we are only having one line here. And otherwise, we are going to set the locomotion status to walk, because again, this is if we are moving forward or backwards while we are pressing the key, because it can happen that we press the shift key, left shift, which is the B run key, and we are not moving. We only press the shift button, but we are not pressing WASD keys. So if we press one of these, then we are going to set the locomotion status to run. Otherwise, it is to walk. Over here in the else, I'm simply going to increase the stamina because we are not pressing. Over here, as you can see, we are not pressing the key. So if we are pressing the key, this is what's going to happen. Over here, if we're not pressing the key, then I am going to increase. I'm going to say plus equals the stamina. And over here, if our stamina is greater than the max stamina, I'm going to set the stamina to the max stamina, not allowing it to go above the maximum. There you go. And of course, I am going to set the locomotion status. So let me just find it here. There you go. Find it and set it to walk, because we are walking now since we are not pressing the B run key. Now over here in the under minimum, we are going to perform the similar test. So if B run key press, so if we press that key, and over here below we are going to say else, meaning we are not pressing that key. So what's gonna happen if we press the key in the under minimum, then I'm going to subtract from the stamina again, delta stamina, and then I'm going to say if the stamina is less than or equal to 0.0 F, so it's equal to 0.0 F. And if that is the case, I'm going to set the stamina to be equal to 0. So stamina is equal to 0.0. And I'm going to set the stamina status, actually set night stamina status, there you go, to E night stamina status, and this one is going to be 0. Because we are at the 0 stamina, what else can I say? Now over here inside or below here, we are going to have an else statement. So else, over here, I'm going to perform another test. So if B move forward or So it's B move forward, come on, or B move right left. So if that is the case, and this is inside of the else statement within the first if statement over here. So don't get confused and put this code inside of here, okay? So if we are moving forward or left or right, we're going to set the night locomotion status to E night locomotion status, and this one is going to be E run. There you go, not the that one, but we want the run. There you go. And over here, semicolon. There you go. And else, if that is not the case, then we are going to set the night locomotion status to the walk, because we are walking. We are a nice little knight who is walking. And let me just format the code. There you go. Inside of the else statement, we are going to do something similar as what we did above. So we're going to take the stamina, add to it the delta stamina, so increase it because we are not moving. And over here, if our stamina is greater or equal to the minimum run stamina, if that is the case, we are going to set the night locomotion status, or stamina, excuse me, set night stamina status to E night stamina, and this one is going to be normal stamina. Otherwise, over here, inside of the statement over here, we're going to set the night locomotion status, and that is going to be night locomotion status to the walk status. There you go. And let me just format the code. Moving forward, what's gonna happen if we are inside of the 0 case? Well, over here, we are going to test if B run key press. So if we press the run key, then we're going to set the stamina to 0.0 because the stamina status is 0. So we are going to set the stamina to 0. Else, if it's not, then we are going to set the night stamina status to the E night stamina status to the recover phase. And then we're going to set the stamina plus equals delta stamina. There you go. And outside of this if else, we're going to set the night locomotion status to the E night locomotion status walk. Because now we are walking, since the stamina is equal to 0, we will not be able to run. And over here in the recover, because we're recovering right now, we are going to say stamina plus equals delta stamina. So delta stamina, increase the stamina. If the stamina is greater or equal to minimum run stamina, then we're going to set the night stamina status to the E night stamina status. This is going to be normal. There you go. And outside of the if statement, set the night. So set night locomotion, set night locomotion status to the E night locomotion. E night locomotion status. There you go. Finally. There you go. So we are basically done with the tick, which is going to allow us to run or make the character run. So Control Shift B to compile everything, hoping that Unreal Engine will not break for whatever reason, and the compile has succeeded. So what I'm going to do is go back over here. And well, now we can test the game. What else should we do? So hit the play button and let's see now if I press the left shift. Look at that. My knight is running. And notice I'm still holding the shift. So look at that. The shift is being held and he was running, and now he stopped while I was holding the shift still, because he got to the point where the stamina decreased. And well, we don't have any more stamina to run, and I can run now again because the stamina has increased. And look, he's running, and look at that, he is running still, and now he stopped. I'm still holding the left shift button, which you can test on your own as well. And as I said, the stamina decreases every single time because we are pressing and holding the B run key. If I go over here, B run key pressed. So this is what we are doing essentially. And of course, inside of our functions where we press the B run key, let me just see that where it is quickly, if I can, find it. And here is our B run key is pressed. And let me just see here where we change the stamina so that I can see where we change the speed. If you are wondering why the speed is changing, which is over here, it happens over here. depending on the status, so if we are in the locomotion status run, look at this, max walk speed is run. And if we are in the locomotion status that is not equal to run, then we are going to set it to the walk speed, which over here we are doing. Notice here inside of our switch and case, so we are setting the locomotion status to run. If that happens, well, you know, the knight is going to run as you just saw. And this will conclude our knight. So now we can go and create our enemy. So over here in the content browser, the mist, and right click and new C++ class. I'm going to inherit from the character one more time. And this one is going to be our enemy skeleton, or you can call him skeleton. However you want to call him, I don't care. Call him Carl, or I don't know, what was your nickname when you were a little kid? I don't know, I don't want to say names over here. But anyways, you get the point. This is my chance to sing to you. And unfortunately, it's close to compiling. But yeah, I'll still have time. Why isn't it compiling? Apparently, I will have to cut this out because, again, Unreal Engine is compiling. Finally, it has compiled. So let me go here and open the folder, or actually I see Visual Studio, whatever is it called. You see, I have issues over here talking. Anyways, go and open the enemy skeleton.h file that you will find in the downloads and copy it here. So simply select everything, copy, and then open the .cpp file for the skeleton and go over here and copy it as well. Now, before we compile this, we do need to go here in the source and the mist and find the .build file. So where is it? Here it is, the mist build file. So open this file, and what we need to do is select these two lines of code. So private dependency module names and public dependency module names, and paste these lines of code. So over here you need to have core U object, engine, input core, UMG, AI module, slate, and slate core. This is because we are using AI over here for the enemy. If I can find it only over here, AI controller, there you go. So we need to have these modules imported, and well, that will be it. Control-Shift-B to compile everything, and voila, there you go, build has succeeded. So what we can do is we can go and create our enemy skeleton inside of our editor. If I can open it, so in the blueprints, right click, and the blueprint class, we do need to inherit from the skeleton. Let me just find it here. Enemy skeleton. Here is the bad boy. BP underscore enemy skeleton. And let me double click it so that we can open it over here in our blueprint editor. So compile and save everything. Select the mesh, and for the mesh over here, we are going to select the skeleton, who is a little bit large, if we can say like that. So I'm going to take the skeleton, set the scale, first lock the scale over here. So 0.18 on all three axes. And the position on the Z is minus 47. The rotation on the Z is minus 90 degrees. There you go. We can also change the capsule size. So it's going to be 44. The capsule have height and the radius 16. There you go. Now, of course, you can change this however you want to change it. That will be up to you. And next, what I'm going to do is take the arm collision, which is the collision that will detect the collision with the player. And what I'm going to do with this one is unlock over here. So uncheck this lock icon for the scale and set the scale to 0.04 on the X, on the Y 0.06, and on the Z 0.003. Almost like James Bond, but it's not James Bond. And that will be pretty much it. I'm also going to set the position to 0.38 on the x-axis, and on the y it's going to be 1.33. There you go, something like that. Of course, we can change this later on in the game if you are not satisfied how it looks like and all of that stuff. That will be totally up to you. I'm also going to select over here our enemy, and for the hit particle, what I'm going to do is select the PS blood Spurt 3, and for the montage it's the NPC combat montage. So compile and save that. Over here for the type of damage, I'm going to set the damage type. Let's compile and save that. And by the way, also over here for our knight, let me see if we set the damage type. So the damage type for the knight needs to be damage type. There you go, so that we can then deal damage to the enemy skeleton when dealing damage time comes. Very clever, right? So let's go here in the skeleton, compile and save that. Let me see if I need to change anything else on the skeleton. I don't think there is a need to do that. No, there isn't. So let's go back here inside of our C++. Okay, we're not going to do anything in the input because the skeleton will not have the input. Over here, everything is already done. Yes, it is. So in the enemy skeleton, we created everything here so that we don't have to wait. I should have done this with the player as well. You can go through these and see what I did, because the skeleton also has the status, which is over here. It has an enum for idle, run, combat, and death. And you get the point. So just go through this. As I already said, this is not a complete beginner tutorial. I expect you to know stuff. Now, no matter which level you are, you can learn a lot in my game development camp. If you're a complete beginner, you can start from scratch. If you are an expert, you can go into the more advanced tutorials, so you have that to learn more. Anyways, over here in the skeleton status, I'm going to take the skeleton status and set it to be equal to status, which is the parameter that's being passed over here. Over here to return the status, I'm going to simply return the skeleton status. That would be pretty much it. Now going back over here inside of the follow sphere, I'm going to say if other actor and R is skeleton, so is skeleton alive. So if we have the other actor, we have collided with it and the skeleton is alive, we are going to say over here a knight, and with an asterisk because it's a pointer, and knight, and that's going to be equal to cast into the knight, and we are casting, so it's a knight. There you go, casting the other actor. If the cast succeed, then we will have the knights over here. If we have the knight, I am going to follow the knight. So follow knight, passing here the knight character, which is going to be followed. Now we will see in a second how we are going to follow the knight. Do not worry about that, because over here inside of our follow sphere on overlap end, we're going to do something similar. So I'm going to copy this code like that and paste it over here. So if we do have the other actor, but we're not going to test if we are alive, we don't care if the skeleton is alive. So if we do have the other actor and we can cast that actor into the knight, if we do have the knight, then I'm going to remove this from here and I'm going to say B is target alive is equal to false. And then I'm going to say set skeleton status to E skeleton status and colon idle. And then from there, I'm going to test if our skeleton controller and skeleton controller, there you go. This autocomplete is weird, you know. And if we do have the skeleton controller, then we are going to stop the movement because the knight has escaped the sight of the enemy. And that would be pretty much it. Now let's go over here in our attack sphere on overlap begin. I'm going to do the same thing over here. So copy these lines of code and paste them here. So if we have the other actor and the skeleton is alive and we can cast the other actor to the knight and we have the knight, then what I'm going to do is say here B is target alive to be equal to true. Then I'm going to say target is equal to knight, and then I'm going to say B stop attacking is equal to true, and then I'm going to attack the knight. So what this going to do is inform us if the target is alive, which is the knight. The target is the knight, and over here B stop attacking is true to stop the attack and then perform another attack on the knight. And let's copy this again and go here in the attack sphere on overlap end. So if we do have the other actor and the skeleton is alive, if we can cast the other actor to the knight, and over here we do have the knight, then what I'm going to do is say B stop attacking, and that's going to be equal to false. And then I'm going to say follow knight character, passing here the knight that we are going to follow. Our target is going to be equal to null PTR, so null pointer, null PTR, there you go. And then I'm going to say get world timer manager, And from here, I'm going to clear the timer for the attack delay. And because we're going to attack with the delay, which we'll see in a second, that is why we are going to clear the timer. Over here in the take damage, we are going to simply return the damage amount, but after or before that, we're going to say health minus equals damage amount, and then we are going to say if our health is less than, not header, whatever this is. So if our health is less than or equal to 0, then what we are going to do is call the die functionality on the skeleton, because we want the skeleton to die. We are weird people. We want our skeletons to die. So next over here in the die functionality, we are going to say anim instance, and it's a pointer. So anim instance is equal to get the mesh from the skeleton, then get the anim instance from the skeleton. If we do have the anim instance, then we are going to say anim instance, and from here montage play finally skeleton anim montage, and we are going to say 1.0f, and then I'm going to say anim instance from here montage jump to section, and we're going to jump to f name, passing here that for the that section inside of the skeleton anim montage, which is going to jump to that animation in the montage that we have. And again, this montage consists of multiple animations that are inside of that single montage, which of course you can learn how to create inside of my Game Development Academy if you don't know how. Now over here inside of our, or after this if statement over here, if we do have the anim instance, we're going to say set skeleton status to the e skeleton status. This one is going to be that. There you go. Arm collision, we are going to set collision enabled, and we're going to set that e collision enabled, no collision. Voila, there you go. And I'm simply going to copy this line of code because we're going to do essentially the same thing for our attack sphere. There you go. And then we're going to do the same thing for the follow sphere. There you go. And last but not least, we're going to get the capsule component, and from it we are going to do the same thing, set the collision enabled to no collision, because now our skeleton has died. That would be it. Over here is our follow knight, which we are calling here to follow the knight, and also over here to follow the knight. So what's gonna happen inside of follow knight? Well, we are going to follow the knight. What else is going to happen? So I'm going to say here set skeleton status over here, e skeleton status to the run status, and then if we have our, so if skeleton controller, if we do have the skeleton controller, we're going to say FAI request, which is not request ID, is FAI move request, excuse me. So move request, and I'm going to call it request, and we're going to say request. Actually, I'm going to call it move request because it's more convenient. So move request dot set goal actor to our knight, and then we are going to set here request or move request dot set accepted distance radius to 12, and this is the distance where our enemy or the skeleton is going to stop before the player. I don't know, let's say over here 7, for example. We can set it to 7. Of course, you can change this later on if we don't like it. Over here, f nav path shared PTR. We're going to say nav path shared PTR. There you go, shared PTR. And did I spell this correctly? Yes, I did. So nav path shared PTR. There you go. And then I'm going to call the skeleton controller, and from him move to, and we are going to move to the move request. So it's move request, and then over here we're going to pass the nav path shared PTR. And there you go. Now, what's gonna happen over here in the attack overlap? So when we attack with the, or when the attack box that we set up on the skeleton's hands, when they, I have issues talking, blah, 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 blah. Anyways, when they collide with the player and detect collision with him. So we are going to say if other actor, so meaning they have collided. And if we can cast, so a knight, and then we're going to call a knight, and that's going to be equal to cast to a knight like that, the other actor. If we have the knight, meaning the cast has succeeded, which means we have collided with the knight. So over here we're going to say if knight, and from here we're going to test if he has the hit particle. And if he does, then we're going to create a constant for you skeletal mesh socket. So it's skeletal mesh socket with a star hit socket, which is going to be equal to get mesh, and from the mesh get socket by name, and we're going to get the hit socket name. Now next we're going to test if we do have the hit socket, not hit particle but hit socket. If we do have it, then we're going to say f vector socket location, that's going to be equal to hit socket, and from here get socket, so socket location on the mesh, get mesh. And why do we need all of this? What is this? Why do we need it? Why do we care about this? Well, because now we're going to call uGamePlay statics, and from it we're going to spawn an emitter at location. This location is going to be in the world space, and then at the knight, or this is the particle that we are going to spawn, hit particle from the knight, at the socket location, f rotator is going to be 0 on all axes, and false over here, which is going to spawn the hit effect where we actually hit the player. Now, outside of this over here, so outside of this whole thing, whatever, you know, we did here that we just explained, whatever we did that we just explained, I mean, I'm doing new things over here, man. I am destroying everything. So anyways, if we have the type of damage, there you go, then we are going to call the uGamePlay statics, which is going to apply damage to the knight at the damage to player, or basically damage to player is the value that we are going to apply to the skeleton as the damage, and then skeleton controller, who is the one that is going to deal the damage over here, this, and then type of damage. What the hell is this applied damage? Well, this applied damage is going to call a function over here inside of the knight, and let me just find that function. So it is going to call this one take damage. So let me just find it where it is, if I can see it, because, you know, we coded a lot because we're good coders. What else can I say? And here it is. So when we call this over here, when we call uGamePlay statics apply damage, passing here the knight, it is going to go through the knight and look for his take damage function, and it is going to call it. So this is what we are essentially doing with this line of code, and then the code inside is going to execute. Now over here I'm going to leave as your assignment, do something. So whatever you want to do in the end overlap, surprise me. I like surprises. As your challenge, be creative, whatever you want to do. And same challenge you have for the knight as well, to do something when the attack ends after the knight has attacked the skeleton. So it doesn't have to be something spectacular, but I truly want to see what you did, so you can post your comments below the video. Now over here, to enable the collision, I'm going to call the arm collision, and from it set collision enabled, and the collision is going to be e collision enabled colon query only, so query only. You can learn more about collisions in my academy in more detail. I cover that in one of the courses, that is. Over here, to disable the collision, I'm going to set it to no collision. Simple as that. What else can I say? And over here, when we attack our knight, we are going to test if is skeleton alive. And over here, we have the B is target alive. So we are going to test if the skeleton is alive as well, if the player is alive. And if we do have, so if skeleton controller, over here, we're going to say skeleton controller, not motar, skeleton controller, and from him stop the movement. So it's stop movement. And then we're going to say set skeleton status to the E skeleton status colon combat, because now our skeleton is combat friendly. So going back over here, if we don't have the B combat, so if we are not inside of the combat currently, then we are going to be right now. So combat is going to be equal to true. And notice the exclamation mark over here. That's why I said if we're not in the combat. So now we are in the combat. That is true. And we're going to say anim instance, and it's a pointer, anim instance. It's equal to get mesh, and from the mesh, get the anim instance. By the way, you can clean up this code, write it better. That is also one of your assignments. So if anim instance, and I want you to submit that in the down below in the comments, okay? So anim instance, and from it we are going to call play underscore montage play. That is, so montage underscore play, and from here skeleton anim montage at 1.3 speed. And then I'm also going to say here anim instance, and from here montage jump to section f name. The name of the section is attack 1. There you go, inside of the skeleton anim montage, and voila. So it's going to play the montage over here, but from the section attack, which is going to make the enemy attack the player. Over here in the stop combat montage, we are going to say B combat is equal to false. And by the way, these are going to be called as events, so we will see that in a few moments. And over here, if R, so if B stop attacking, which is going to happen over here inside of the stop combat montage. So if we should stop attacking, then we're going to say float next attack to calculate when the next attack should happen, fmat, and we're going to use frand range, and the range is going to be from minimum time to next attack to the max time to next attack. And this is randomized because we don't want to allow our enemy to attack like a crazy person, you know, gazillions of times. Then we're going to get the world timer manager, and from him set the timer, not pause the timer but set timer, and we're going to set the attack delay timer. And this, and inside, or the function that we are going to call is a enemy skeleton colon attack night, voila, and in the next attack time interval, voila. That would be pretty much it. In the end montage at that pose, meaning when we die, then over here we're going to get the mesh. And by the way, I don't think anything here is unclear. We have covered time manager gazillions of times, even on my YouTube channel, especially my Game Development Academy. I'll show you different ways how to use it and for what. So this should be pretty much clear. If it's not, ask in the comment down below. From here, get the mesh B, pause anims is equal to true, get the mesh, and from here, B, no skeleton update is equal to true. Then we're also going to get the world timer, or world timer manager, set timer. So I'm just going to copy this from here. So copy it. Let's go here, set timer at the destroy skeleton delay inside of this. And then over here, we're going to clear actor, which is the one that we're going to call inside of our delay skeleton destruction time, which is going to call, you see, this function clear actor. Now over here is skeleton alive is going to return get skeleton status, and we are going to test if it's not equal to E skeleton, so it's E skeleton status colon E death, not combat but death. So it's going to return is the status of the skeleton equal to the death status. Over here in the clear actor, we're simply going to call the destroy functionality, which is going to destroy the skeleton. Now I know we coded a lot, we basically finished the enemy class, but all of this, as I said, should be crystal clear to anyone who has, you know, created at least one game in Unreal Engine. And if it's not, make sure to ask in the comment down below, and enroll definitely in my academy to learn more if you don't know these things. But if you don't know something specific for this code over here, you understand the majority, but you don't know some specifics, make sure that you ask in the comment down below and I will help you out. Now we can Control-Shift-B to make sure that I didn't do any oopsies. And there you go. We didn't do any oopsies. Build has succeeded indeed. So now we can go inside of the editor and we can test it out. So what I need to do is take the skeleton dude and move him over here. And yeah, he can be over here, something like that. It's okay. It's important that, you know, we don't touch him right away, because when we touch this circle, he should start chasing the player. But in order for that to happen, we need the nav mesh bounds volume, which I'm going to position over here. So the nav mesh position is going to be -48, and over here -124, and on the Z is 38. And then over here, I'm going to set the scale to 6.25, and then 7.25, and then over here 2.5, because we need the bounds volume in order for the skeleton, or the skeleton's AI, to be able to calculate where it can move and all of that stuff. So that is why we need to use the nav mesh bounds volume. If you want to learn more about this, I have that in the very first course in the Academy about Unreal Engine. So now when we come close to the skeleton should start chasing us. And there you go. Look at that. The skeleton is chasing us. And of course, he will be continuing to chase us until we, well, run away from whatever of his bounce. Now, of course, he is too fast because our knight is slow. So I can select the character movement. And over here for the maximum walk speed, I don't know, let's set it to 100. This is just for testing purposes. Later on, you can change that so that we can see it more clearly. But now when we get close, look at that. He is coming, he's near, and the song, you know. Anyways, moving forward, there you go. We have the skeleton. Of course, he is searching for us. If I go outside of the bounds of his circle, look at that. Now he is standing. And there you go. So we have everything in place when it comes to the skeleton and the weirdness of the skeleton chasing us and yada yada yada. Now we can go inside of the C++ classes and we can create the animation instance for the skeleton. So over here, anim instance, there you go. And I'm going to click next, and this one is going to be enemy skeleton anim instance, and hit enter so that we can, you know, create it, because we need to use it, and if it's not created we cannot use it. And hopefully I can start singing. And unfortunately my song has ended there, but yeah, you're not here for my singing, you're here for the learning. And let's go here, and what we're going to do inside of the .h file is have these public ones, and this one's going to be virtual void native initialize animation. There you go. Override something, same thing that what we did for our player. This one is going to be u function, and it's going to be blueprint callable with capital C, so callable. And this one's going to be void update character animation properties. Voila. Then we are going to say here u property, not proper to, it's property. And this one's going to be edit anywhere, and then blueprint read only, so read only. Voila. And this one is going to be float character speed. As I said, same as what we did with the player. So you property, you can pause the video and try to do the same thing. You need to update everything, so the movement, the character, and stuff like that. So that can be a challenge. Edit anywhere, and this one's going to be blueprint read only. It's only, not only a, it's only. There you go, finally. And this one's going to be a pawn, which is a pointer. I'm going to call him pawn, and you property. And from here, this one's going to be edit anywhere, and then blueprint read only. And this one's going to be class a enemy skeleton enemy. Voila. There you go. There you go. There you go. Now, what we are going to do with this bad boy is go here inside of .cpp file. But before that, I'm going to select this one over here, quick actions and refactoring, and create the instance, or actually create the definition of the method or the function inside of the .cpp file. And finally, it has worked. For whatever reason, it takes too much time. I'm going to copy this over here and paste it so that I can go here and copy the native function and also declare the native function. Also here we need to include the enemy skeleton.h file because we're going to use the enemy skeleton, which is going to happen over here. So if our pawn is equal to null ptr, then we're going to say pawn is equal to try get pawn owner, which is going to get the owner of this enemy instance, which essentially is the enemy. If we do have the pawn, then we're going to say skeleton enemy is equal to cast into, so cast into a enemy skeleton and casting the pawn so that we have a reference to our enemy. Next over here, I'm going to say if our pawn is equal to null ptr. If that is the case in the update, then pawn is equal to try get pawn owner. And basically we're repeating this, but again, you know, from the very start, I have laid out some rules for you. So yeah, that is your assignment. Think of it through what you need to do. Think of it through what you need to do. In the crew, I don't know. Anyways, moving forward, if pawn, so if we do have the pawn, then we are going to say f vector, which is going to be speed, is equal to pawn, and we're going to get the velocity from the pawn. F vector, this is going to be horizontal speed, that's going to be equal to f vector, and this is going to be speed dot x, speed dot y, and 0 on the z-axis, and our character speed is going to be equal to horizontal speed dot size, which is the magnitude of the vector. And if you don't know what is the magnitude, I covered that in the Game Development Academy, which you can take a look at, along with a lot of other bunch of really cool courses and tutorials for you to learn. So I don't know why you're avoiding the academy. Go and check it out. Link is down below. So over here in the content, I'm going to right click and create an animation, blueprint animation that is, which is going to inherit the enemy skeleton anim instance, and it is going to inherit the skeleton, not this one, I believe, not skeleton cube. I think this is over here. Yeah, game NPC. I believe it is. Let me just make sure so that we don't make a mistake. So this skeleton is located NPC, there you go. So game.npc. Let's go back here and right click and animation and blueprint animation. So enemy skeleton anim instance, and we want the skeleton from the NPC. There you go. So BP, and I'm going to call this one skeleton anim, like that. I'm a skeleton. Anyways, moving forward, and no, I don't listen to these two weirdos. If you understood the melody. Anyways, going here in the event graph, we are going to update character animation. So update. There you go. Finally, we have it. I'm going to right click and get here some notifiers. So we want the stop attacking notifier. We also want the collision on notifier, so collision on notifier. We also want the collision off, so collision off notifier, as you can already, assume. We also want over here the attack one, end, so end attack one that is, and over here we also want the death, and let's see that. Voila, there you go. So what's gonna happen over here in the stop attacking? So first things first, we need to get the skeleton enemy. And from him, what I'm going to do is get the stop attacking. So stop attacking, I need to get that, and we need to enter a branch over here. And the condition is the stop attacking for this branch. So what's gonna happen if this branch is false? So if it's false, we're going to say if is valid with a question mark. We want this one. And we are testing, and from the skeleton enemy, I'm going to get the target. So getting the target, who is going to be tested if is valid. So do we have the target? And the enemy goes here. There you go. This can go here because we will still need to get the, from here, we need to get the follow knight character. And let me just see what I did here. So this is from here, follow knight character, which we do not have for whatever reason. We need to go back over here inside of our enemy skeleton.h. Let me just find the function. So follow knight. Yeah, follow knight needs to be blueprint callable. Let me just see over here. So follow knight character, here it is, blueprint callable, new function, blueprint callable. It has the knight, so everything is okay over here. Let me just check it out. So if it is valid, we're going to call here follow knight. Can we do it like this? Yeah, for whatever reason we had to turn off context sensitive. I don't know why I didn't find it. I mean, we were calling it from here, so follow knight, but if context sensitive is on, for whatever reason, I don't know. Anyways, you get the point. So there you go. And it's the knight that we are following. Well, actually, I think from here I have called, if I have called it from here, follow knight, yeah, there you go. And even if the, well, no, doesn't matter. You get the point. We have what we want. But I am surprised why didn't it work. So let's go here, and for the collision on, I'm going to go here and say enable weapon collision. There you go. And this function is callable. Look at that. So this function is callable for whatever reason, and this one is disable weapon collision. So this goes here like that. And next we have the end attack one, which is again going to take it from here. Voila, there you go. And this one is going to be stop combat montage. And I'm going to plug this bad boy here. And then we are going to call end montage at death. And let's go over here and plug it in. So compile and save that. And result was visible but ignored. Therefore, target must have a connection. Okay, I understand what is wrong. So the target needs to be R. It needs to go from here. So this goes here, and the knight is there. The target can be plugged in from here. There you go. Let's do it right now. Compile and save. Voila, there you go. These notes have confused me. Why didn't they call the follow knight character? Anyways, I do not care. I do not care at all, you see, because I'm a bad boy. Let's go here in Dynam Graph and create animation. So I'm going to right click in state machine, and I'm going to call this on locomotion, and then I'm going to cache the state machine. So I'm going to cache, new saved cache pose, which I'm going to call locomotion cache. And I'm going to cache it from here, and then I'm going to get the locomotion cache, and I am going to right click and get the slot default and plug this in here, plug this in the final result, but the slot is going to go into the combat slot. And don't think of weird names or think of weird things when I say slot, okay? So from here, I'm going to right click and add a state. It's going to be our idle/run. And I'm going to plug it in over here. Let's go inside because we are going to get the idle run, which is the blend space that I'm going to plug in here. And we're going to get the character speed, which is going to go over here, voila, and compile and save that. So everything works fine. We see the animation over here at the top left corner. Make sure compile and save. Go into the enemy skeleton, select the mesh, and for the anim, BP skeleton anim, and right away you can see compile and save that the enemy skeleton is, working. And that would be pretty much it. We can go back over here and save. So now when we get close, we should see the skeleton also being animated when he runs towards us, which is the case. Look at that. And when he gets close to us, he should be attacking. Look at that. And we also see the blood spatter. You see that? You saw it. I mean, you're not blind. You saw we have the blood spatter and all of that stuff. Now, the last step that we need to do is inside of our night script. So inside of the night script, we do need to go, let's go back over here. Let me open the night script, night.cpp, which goes all the way here at the top. And then from here, we are going to go and we need to include the enemy skeleton.h. So we have the enemy skeleton.h. Now what we need to do is when we collide with the enemy, so the sword overlap. And let me just find that over here, sword overlap, which is down below, hopefully. Where is the sword overlap? Let me just find it. Sword, overlap. Where is swordy? I said we will do this later on when we create the enemy, if you remember when we did all of this here. So it should be somewhere around here. Start combat. Here it is. We'll be done when we create the skeleton. There you go. So if we do have the other actor, then what we are going to do, enemy skeleton, and over here we are going to call the skeleton or create the skeleton, which is equal to cast, and we're going to cast to the enemy skeleton, and we're casting the other actor. There you go. And if we do have the skeleton, so if we have the skeleton, then we are going to do weird things. So let me just compile and save this, and let's go quickly over to the player, actually to the testing phase inside of the editor. And if I hit the play button, let's get to the skeleton who is going to attack us, because I want to show you something. So come on, Skelly. Hopefully, and this is the wait between the attacks. So we are not allowing the skeleton to attack a gazillion times, attack. And there you go, look at this. Now we have issue over here. The player is not dying where he is supposed to die. I cannot move the player, I cannot attack, I cannot do anything. He is supposed to play the death animation right here. I want you to fix this issue. So this is left on purpose. I want you to fix this as a test for you. And as a last test for you, I also want you to code everything over here. What will happen when we, attack the skeleton? And basically what's gonna happen is you're going to deal damage. You are going to spawn a particle effect, same as how we did for the enemy when he attacked the player, and you're going to kill the enemy, and that's it. And after that, what I also want you to do is the following. Then you're going to go, now we have all the blueprints, ingredients. We are going to go in the island. Yes, save everything over here in this level. So we are going to go here in the island, and the navigation has been built. So over here for this island, the project, the map and modes should not be changed. There you go. If I hit the play button, we should see the player. Voila, we have the player, and we will be able to run, as you can see. I want you to lay out enemies inside of this level. So the enemies should be laid out in the level, and I also want you to create an enemy goal, or not the enemy goal, but the player goal, somewhere where the player needs to reach that goal in the level, so that you reach that. Of course, you kill the enemies and then you reach that, and then the level finishes. So that is also your assignment that I want you to submit in the comments down below. You can post a link, because this is on YouTube. You can post a link to the project. I can check it out and stuff like that. Or if you are in my Game Development Academy, you can post it in my academy in any of the lectures. Just tell me it's regarding this project and you want me to check it out. I will check it out, get back to you. One other thing that I want you to solve is also this. Look at this now. If I go here, I will be able to bounce. If I attack the enemy, he should be bouncing off. For whatever reason, he's not. But if you look at that, you saw that he bounced out a little bit. But if he doesn't bounce, you will see when you play, he will bounce off when I hit him with a sword. He's not doing that right now. doesn't matter, but you get the point. Also, I want you to solve that issue, and yeah, that will be pretty much it. Now, this is a basic adventure game. It's not like we have too many features, but we did learn a lot of stuff, especially if you are not that complete advanced. If you are a beginner who created 1-2 games, you did learn a few things, especially the combat stuff. And if you did all the assignments that I gave you, then you definitely gained a lot of knowledge. Anyways, if you want more of this, more advanced, more detail, now this is a basic detail. You know, in my academy, I break it down. I will show you everything line by line, step by step, how you would create this level, how you would do everything in my academy, of course. So for that, link is down below. And yep, Fire here from awesome2.com. Thank you for watching this tutorial, and I will see you guys in the next video.